Hello and welcome again. So we're on topic 2, ecology for IB ESS. Section 2.5 deals with two important processes that occur in the environment, primary and secondary succession. But of course, section 2.1 also deals with the classification of organisms and with dichotomous keys. In the past, I've made extensive videos on the details of all of these, and they will be linked in cards and below this video on YouTube. But right now, I want to introduce to you an important model. Here, this model, of course, is a system. It is an open system, if you remember, an open system made up of all of these components. Open because it exchanges both matter and energy with the surroundings. Oxygen gas can come and go, but this bamboo shoot that's growing inside of this vase here was put into my classroom in August of 2024. And as our semester went by, I observed the development of algae inside of this container. Now, as we study succession, I want you to think, is this primary succession or is it secondary succession? Primary succession you might read of in your textbook. It's when you have bare rock, a brand new island that might appear in the middle of the ocean like Surtsey and Krakatau and other places that volcanic eruptions occur below the ocean and an island forms. And then in time life develops on these surfaces. How much life would develop might depend upon where in the world the island is formed. If it's formed in the tropics, likely that life would develop faster. If it's formed in the tundra, it might be that life would take much longer to develop and the process of succession would take a little bit longer. But here, this system that was created, a man-made system albeit, but in time, these algae began to grow inside of here. And it didn't happen overnight. It took several weeks or months before the presence of any algae could be seen. And now, 6-7 months have gone, and there's a significant amount of algal growth inside of here. These are, in a sense, pioneers. Just like lichens and mosses when we have bare rock, this too is its own type of primary succession. And if I were to go ahead and clean this entire container out, pour all the water out of it, but leave the rocks at the bottom, leave the bamboo in there and refill it with water, chances are that the algal growth will return much faster. And that would be an example of secondary succession. And we would be modeling a natural process also, not a fire, but in this case, a process where all of the water in an ecosystem might disappear. Very often in textbooks, we talk about secondary succession happening after a fire rages through a forest, which is a good example. But there are other ways for life to disappear from a particular habitat or ecosystem. And one way is through a drought, which would ravage the entire aquatic environment, remove the aquatic environment, and in time, when water refills the system, when the rains return, how difficult would it be for life to return to the lakes and the waterways in that habitat? It might be that the algae would return much faster than when we had the initial process or the primary succession. And if that's the case, then we can carry out that activity and find out. And that we will do. But first, it's important for us to identify the type of algae that we have in here. And how do you, if you have algae growing that you don't know what its name is, how can you find out what it is? And that is why we have something called the dichotomous key. So we can observe the morphological characteristics of this, what it's made up of, what it looks like, and understand the vocabulary that goes along with describing algae. Once we educate ourselves about some basic biology of algae, then we can use the specialized key that biologists use, made by biologists for biologists. That's the nature of the true dichotomous key. After all, you don't see someone going in the Serengeti to look up a key to identify a lion or a zebra or any such thing. Keys in textbooks that use clothing and cars and big animals to talk about the concept of a key are all good. But that's not why the dichotomous key was made. It was made by biologists for biologists so that you could identify something that is fairly obscure and not well known if you have the background knowledge and you know what a filamentous alga is, you know what a nucleus looks like, you know what a cell membrane looks like, you know what chlorophyll and chloroplasts look like. So let's move into that lesson and take a closer look. We are going to take this algae out of here, put it under the microscope, and try to identify it using dichotomous keys.